Hello, Science Fam. We have been learning about half-lives, and now it's time to put the pedal to the metal and do some half-life practice problems. So if we start, let's just simply start by reading. The half-life of cesium-137 is 30.2 years. So already I know that the time it takes for this cesium-137 to decay to half of what it was takes about 30.2 years. All right? So first of all, make sure you understand what a half-life is. We know the initial mass of the sample is going to be 1 kilogram. All right, so the starting mass, the initial mass, so I'll put a little I for initial. The initial mass starting is 1 kilogram. I want to know how much will remain after 151 years. So my total time, my time total, TOT for short there, is going to take 151 years. All right? What I'm looking for is how much remains, right? So I'm going to build myself a little chart to help me with this problem, all right? So the little chart, I'm going to put half-lives. I'm going to put the mass. And since we're dealing with years here, I'm going to put the years for my time frame, all right? What this little chart is going to do is it's going to allow me, sorry, a little wonky with my writing there. Half-lives, mass, and years. It's going to allow me to kind of keep track of everything. So first of all, before any time has gone by, so 0 years have gone by and no half-lives have gone by, meaning 30.2 years haven't passed, we know the starting mass of this object was 1.0 kilograms, all right? We know that it sits for 151 years. So if one half-life passes, we know that that's a total of 30.2 years. Why? Because one half-life is equal to 30.2 years. All right? So what I'm going to do is I'm going to start going through all my half-lives till I get to 151 years. What that will do is it'll allow me to figure out how many half-lives I've been through, and then from there I can figure out how much mass is left over. So if another half-life or 2 total half-lives went through, I would have another 30.2 years, so I would add that, and I'd have 60.4 years. Then I'd go through another half-life, and if I added another 30.2 years to the 90.6, or I'm sorry, another 30.2 years to the 60.4, I would get 90.6. From there, if I went through another half-life and I added another 30.2 years, I would end up with about 120.8 years that have passed. But I'm not there yet. I need to get to 151 years. So I'm going to say if I go through 5 half-lives, add another 30.2 years, I get to 151 years. All right? So what does this tell us? It tells us that this cesium-137 object has gone through 1, 2, 3, 4, 5 half-lives. Well, what does that mean? That means that the mass that it started with, 1 kilogram, right, has been divided in half 5 times because it's gone through 5 half-lives. All right? So all we have to do is divide out what we start with for the mass by 2 5 times. So 1 divided by 2 gives me 0.5. If I take 0.5 now and divide it in half, I get 0.25. If I take 0.25 and divide it by 2 in my calculator, it gives me 0.125. If I take 0.125 and divide it by 2 in my calculator, I get 0.0625. And if I, yet again, one more time divide that in half, I get 0.031 about. So this is my end line. What does that mean? Well, I'm looking for how much will remain. So in kilograms, I am going to end up with 0.031 kilograms for my final answer. Because after 151 years, that is all that is left of that sample. And the reason we know that, for every time it goes through a half-life, every 30.2 years, this object's mass is going to be cut in half. All right? So that was the initial starting one. Let's do another example. Let's go to number 2 to try to get the idea and kind of work out some of the kinks, but hopefully better understanding the half-life problems as well. Okay, so we made some room for question number 2. Let's go. Given that the half-life of carbon-14 is 5,730 years, So that means the half-life of carbon-14 is cut by 50% every 5,730 years. Sorry, I'm not sure if I said that right. So every half-life, the mass of carbon-14 is cut in half, and that takes 5,730 years. Now, consider a sample of fossilized wood that when alive would have had about 24 grams of carbon-14. So that means the starting or initial mass is 24 grams. It now has, so the final mass, the mass that we see now today, there's only 1.5 grams of carbon-14 left. We want to know how old the sample is. So basically the total time. How long has it been sitting there? All right, we can do that. Let's do our chart like we did for the last problem. We did half-lives, we did mass, and for this one we're dealing with years again because the half-lives in years, not seconds or hours or minutes, so we'll deal with years. Let's start this to figure it out. So remember, when no half-lives have happened and no years have passed, this object started at 24 grams, all right? Fine. Now, after one half-life, we know the mass of that object was cut in half, right, to 12 grams. Okay. Now, after two half-lives, this was cut to 6 grams. Why? Because it's cut in half every half-life. After a third half-life, it's cut in half again, and we have 3 grams because 6 divided by 2 is 3. And then after fourth half-life, you have about 1.5 grams left. All right, so now we know that this object must have gone through 4 half-lives in order to end up with 1.5 grams. The reason I didn't do the years yet is because I can add them up now. I know after 1 year, it takes one half-life, it takes about 5,730 years. Now, if 2 half-lives gone by, we have to add another 5,730 years. So that means I add 5,730, and I get 11,460. Now, since you go to another half-life, you have to add another 5,730 years, and that gives us 17,190 years. And after that, we have to add another 5,730 years, and you end up with a total of 22,920 years. So what does that mean? That means this object sat around for almost 23,000 years, and now only 1.5 grams of carbon-14 remain. And that happened because it went through 4 half-lives. But the question is asking how old is the sample? So therefore, we want to give our answer in a time frame. So the time total, or how old the object is about 22,920 years old. And that would be our answer. All right, Science Fam, thanks for hanging in there. Check out another couple of problems. I think I've got 3 and 4 in another video. So see if you need that help and walk through it, or check your answers and go from there. Have a great day.